Alright, welcome back to our series on creating generative sequencers in Reaktor. In this video, we're going to continue working on our project from the previous two videos, and in particular, we'll be working on adding MIDI output. So we're going to need to do a few things there. We're going to need to generate a scale, and we're going to need to choose notes from that scale to be triggered, and then we're going to need to do the actual MIDI output. So one of the things I'm going to want is this polyslider object that I created in a previous tutorial, and if you search our site for polyslider, it'll come up. So I'm just going to copy this and I'll paste it into our project. And so the polyslider is what we're going to end up using to select notes from our scale. And we're going to need to make a few changes to it in order to get it to do what we want. Right now, the polyslider has a number of objects equal to the number of voices in the ensemble or instrument that it's inside. Speaking of which, let's create a new instrument and put all this stuff inside of it. And we're going to give this instrument 32 voices. And I'm going to set everything to mono that we've created so far, besides the polyslider. We want to keep that as a poly object. So you can just select all that stuff and right click and choose the set to mono option. Now hopping inside the polyslider, as I said, it limits its number of objects depending on the number of voices in your instrument or ensemble. And I want to make that change, and it's not going to be that difficult. We just need to find the voice info modules, and anytime something is using the voices output, we'll just simply change that value to whatever value we want our polyslider to be limited to. In this case, we're just going to use the X size. The size of our grid is going to be the limit on the number of objects that we can have access to. And so this means we'll be able to fit the polyslider on top of our grid, and it should always have one slider for each column of the grid. And we'll see how that works in just a moment. I'm just changing the origins of the poly displays here. They were -1 to 2. We're just changing them. I'm sorry, they did go from -1 to 1, and I'm changing them so that they go just from 0 to 1. And you can see our polyslider right now is quite a bit of a mess. Probably still a bunch of things I haven't set up properly. So yeah, we want to set it up so that the width of our poly displays are 768, and I'll give them a height of 64. So 768 just is the width of our grid, if you don't remember. So we're just making these objects the same size so that they can all be layered on top of our grid objects. And we'll change the XY object in the back macro as well. That's kind of creating the backdrop for our polyslider. Now we need to give our macro some values, some input values for the range and step size. So the range is going to be 31, and the step size will be 1. And that is going to give us some values ranging from 0 to 31. And we also need to set the number of voices, which we currently have as 0 because it's not connected to anything. So once we hook that up, I think our poly slider should start working. I've tried a few times and it's not responsive to mouse clicks at the moment. So once we feed it the poly slider input, the size X input here, everything should work. So let's wire that in. And see, each column has its own slider now, and we can drag the mouse across and set the values of each slider individually. Alright, so this is just a handy object to have around, and I have several similar builds around. I'm not sure if the tutorial, this is the exact one from the tutorial, but it should be extremely similar if it's not exactly the same. Alright, so everything's working. Now we have this polyphonic value coming out of our poly slider, but we actually need a mono value because everything else in our ensemble is monophonic. And so like the core cell, we want to give this information to the core cell, but we can't wire a polyphonic signal into a monophonic core cell, not successfully anyway. So we need to create another macro that is going to take this signal and translate it into something we can use in a monophonic format. So let's hop inside our new macro. And we want to do a couple things in order, so we'll create an order module. And we're going to need a voice info module as well. And what's going to happen is we're going to store the voices, the V output, into a value module and then trigger it when we receive a new event at the input. Then we're going to take that voice number, that's going to be the index value, and we're going to use it, the voice number, to control a from voice module. So we're going to take the value from that voice and send it to the output. So that's whenever you click on the poly slider, you can only change one value at a time, and so that'll be the value that's currently changing. So I'm just creating two new inputs in our core cell here, and they're going to be the index of our new value that's changing, and then the value itself. So we have our poly slider, and that can store up to 32 values at once, depending on the size of the grid. And so we want to take those up to 32 values, store them in an array. And in order to do that, we're going to need both our value and the voice number of our current event. So I'll take the output from our event combiner here, and this is going to become our index. Alright, so when we receive a new event here, the voice that it's on will trigger the value module, which will give you the voice number, which we will then use as the index to store this value in an array. And we also use it as the from voice module input to tell us which voice we want to snag a value from in this polyphonic signal. And so we send both of those values to core, and we'll use those in just a moment to choose some notes from the scale that we generate. But first we're going to need to generate the scale itself. So in order to do that, I just want to create a new macro, and this macro is just going to contain a few knobs and an iterator for us to use to generate some notes with. So I'll create a knob. This is going to be our bass note. It's going to be the lowest note in our scale, and I'll let it range anywhere from C2 to B2. So we'll just get, you can choose any note in the 12 tones, and that'll be the bass note. And of course you can set this to be whatever you want, as long as it's a valid MIDI note number and it's not too ridiculously high. It should be fine. And I'm going to use an order module with that because we want it to do a couple of different things. We want it to send its value directly to the core cell, and then we want to trigger an iterator. We want to make sure that the value is already arrived in the core cell when the iterator goes off, so that we can use it to create a proper scale with a knob value that we just created. So I'm going to create another guy here, and it's going to be the mode. It's going to range from 0 to 6, and this is basically our scale type. So we have a bass note and a scale type. And the mode just refers to Western modes of music theory, which are basically just a really simple way to generate a large subset of scales, you know, used in classical music and stuff like that. So now we want to make both of our knobs, as I said, trigger an iterator. So once we have the knob values into core, we want to use them to iterate through some values and create a new set of notes to choose from using our poly slider. So we have a couple of different layers of abstraction happening here, but it's going to be pretty useful for creating a fairly simple structure at the end in terms of the amount of wires moving around and stuff like that. It's going to be a pretty small structure for what it's capable of doing, in my opinion. Alright, so we're going to need some new core cell inputs to wire our key macro into. And we can name those bass and mode and key index. So we're going to create a sequence of values beginning at the bass note, and exactly how it proceeds from there depends on the mode, and we'll use the series of events coming from the key index to kind of make the sequence happen. So we can wire our key macro into the newly created core cell inputs, and you can see the wires are turning red. We just need to set the key macro to mono and everything should be fine. So once we're back inside core, as I said, we're creating a sequence here. So we're eventually going to want to store that sequence inside a new array, and the sequence is going to be 32 notes long. It's going to start at the bass note, as I mentioned. So we'll create an array that has 32 values to store it inside. And basically what we're going to do is we're going to set the 0 index to the bass note, and then from there we're going to proceed by either adding a half note or a whole note to each successive value that we create. So we're going to want to read out the previous note in most circumstances, and then we'll add either a 2 or a 1 to it, depending on what part we're at in our scale. So I'll use a compare and a router, and we just want to make sure that the key index is not equal to 0. So key index is equal to 0. If it is, we're just going to use it to trigger a latch, and the latch will hold the bass note. So whenever the key index is equal to 0, we just trigger this latch holding the bass note. It's in the library somewhere. I'll just hit enter and type latch. So fill that with the bass, and like so. And we'll eventually merge that with whatever value we create when the key index is not equal to 0. So as I said, we're going to want to read a value out of our array in most circumstances before writing to the array. And the key index is where we're writing to, and the merge output is the value being written. Alright, so now when the value is equal to 0, we write the bass note. In other circumstances, we'll use the key index to decide which part of the scale we're at and use that to generate a new value. So I want to subtract 1 from the key index. Therefore, our first value that comes through there, after we subtract 1, it'll be equal to 0, and that'll tell us, okay, we're starting from the first step. I'm going to create a table that's going to store all our steps. It's going to have 7 notes. And we're going to go whole step, half step, whole step, whole step, whole step, half step. Now, if you don't know Western music theory, congratulations, now you do. Literally, this is how you make every single scale in all of Western music theory. Uses this same exact pattern, and the only difference is where in this pattern do you start. So if you start at the 0, that's a major scale. And if you start at, I believe the 5 will generate a minor scale, and then the other ones will generate the various other modes that exist in Western music. So we want to read out the previous value in our array, so we'll subtract 1 from the key index, and we want to add it to a value that's getting generated from our table. And as I said, the table, it all depends on which part of the scale are we at. So we took our key index, we subtracted 1 from it, then we're going to add the mode to that. And so that's going to change which sort of scale we generate. So if the mode is equal to 0, we'll generate a major scale. If the mode is equal to 5, we'll generate a minor scale. So we can generate different scales using this same pattern here. So we take the mode, or the step in the scale that we're at, and we send it through a div mod equal to 7. So we get a value out of our modulo output ranging from 0 to 6. And as I mentioned, our table has a size of 7, so the indices range from 0 to 6. So we're going to read out one of the values from our table here. It's going to be either a 1 or a 2, and we can add it to the table coming out of, the value coming out of our array. And make sure you use an x plus 1 or x plus a adder here, and that you send the array value into the bottom half, because you only want to use that when the key index does not equal 0. Alright, so this should generate 32 notes in some given scale that you've selected using the base note and the mode. And we want to select some note out of those 32 notes using our polyslider device. So it's a lot of kind of complicated things going on here, but at the end of the day it gives us a very abstracted method to set up our scales in a way that isn't totally forced. Like we could just generate these scales and have each column trigger a different note in the scale, one up from the previous, but that becomes really boring, and I did that at first actually, and I really just didn't like the results, so I decided to add in an extra layer of abstraction here so we could choose the notes within the scale individually. And so to do that, we're going to create a second array here, and it's going to store all the values from our polyslider that we created earlier. So we'll just wire the index value and the note values into the right macro and create a quick bus from the OBC connection at the bottom. And then we'll be able to read out from this macro on the other side of our core cell here. And we're going to want to create a couple of different outputs. We're going to create one output that is when we have a new note being triggered by something moving up or down, and we're going to have another output when we have something being triggered moving left or right. So the time when we have a MIDI note to trigger is that whenever we have an event at the up reverse, down reverse, left reverse, or right reverse quick buses. And so we'll use whatever the X and Y positions of the move value is when that happens. So in order to do this, we'll create an idivmod macro, and the top input is going to be the move index. So this is the value that's coming in as we are calculating all of the movements of the nodes in our grid. We'll use 32 as the bottom input, and then the outputs are going to be named move X and move Y. Move Y is the top output. Move X is the bottom output. Just to be clear, don't mix those up. Alright, and so those are, if we have a value at up reverse and the move X value is 1, that means that the event that we're triggering occurred in the first column, or really the second column, because there's a column that has an index of 0, then another one that has a column index of 1. So it would be the second column that we have an event at, and we can use that number to read a value from our array. So this happens, as I said, whenever we have an event at the up reverse or down reverse. We're going to trigger the move X value. So yeah, right now these would range from 0 to 10, moving across from left to right, and then the ones up and down move from 0 to 10, starting at the bottom and counting upwards. So we have our 2 new core cell outputs that are eventually going to trigger MIDI notes. And we want to know what the Y value is if we have an event moving left or right that gets triggered. We want to know which row did this occur on. And these can be used to read values from our array that we filled up using the polyslider on the other side of the screen there. So this is saying now we know which column we were at, which note did we select in that column to be triggered. And then we can use that value that comes out of there is going to be anywhere from 0 to 31, and we can use it to read out from our array over here that has our notes that have the indices ranging from 0 to 31 as well. So we have 32 notes over here that we're selecting from using the polyslider values. So yeah, this extra layers of abstraction is probably pretty confusing, but it's certainly very useful and very powerful. So now we have created a scale that spans several octaves, and we can choose any note along that scale, and then we can change the scale and have the notes kind of stay in the same relative position to each other. So it's pretty cool. One thing I screwed up, however, is the note index. We want to subtract 1 from it over here. The reason for this is our notes are valued, ranging from 1 to 32, and then our array indexes are 0 to 31. So if we subtract 1, then the numbers are the same. Alright, so at this point in time, we should have MIDI note values coming out of our outputs down here, and we just need to find something to do with them. We need to use them to actually trigger MIDI notes. So whenever we have a single event moving around things, we could have a MIDI event happening at the row that event occurs on, and also at the column that it occurs on. That's why we need 2 outputs, is we could actually generate 2 different events. But not more than 2. We couldn't possibly create 2 MIDI notes on 2 different rows with the same move event. It wouldn't work like that. Alright, so we have this monophonic value coming out, and we want to send it to a polyphonic MIDI device so that we can have multiple notes active at the same time. So whenever I get a new input, I just want to add to a counter, and then we're going to modulo by the number of voices in our ensemble. So we'll use the voice info and use the voices output here. And so this way our notes will range, the first one will be on, the first voice, the second one will be on the second voice, and then so on and so forth. And every new note will select a new voice to be on until you hit the limit, and then we'll wrap it back around. Start over from 1 again. So take the output of the modulo and add 1 to it, because our voices, like I just mentioned, start counting from 1. Alright, so this will give you a value ranging anywhere from 1 to the number of voices in your instrument. And then we can use that to send the value to that particular voice. Create an input and an output. Looks like I already had an input that I forgot about. No big deal, we can just delete one of them. And alright, so we want to send our MIDI notes to a polyphonic value. So we'll send both of our MIDI notes through these 2 poly macros. And then I just want to create a very simple note generator at this point in time, and we can kind of improve upon it in the next video. So I'll use an order module, and the order module is going to flow into a note out module, and we'll just send it directly to the pitch. And then we also want to use the third output of the order module to trigger a hold module. And the hold module is going to trigger the gate function of the note module. So the hold module, we just want to send a value of 1 to the trigger input, and that way we'll always just trigger a node at maximum velocity, and then we'll hold it for I think the default time is 300 milliseconds, and that'll work fine just for testing today. And as I mentioned, we'll spruce it up a bit in the future, make something a little more nice to use. So we'll just duplicate this little section here and wire it into the bottom as well. And now I just want to do some testing. So we should see MIDI notes coming out of the MIDI indicators here. And there actually aren't any, so that means something's screwed up somewhere. Oh, and there it is inside our 2 poly macros. We just have some red wires going on. We need to set this stuff to be mono, because it's all flowing into the 2 voice module, which is a monophonic module. And once we do that, everything should clear up. We should see some MIDI notes happening at our outputs. Yeah, whenever we get a collision at the borders there, you see we get some MIDI notes happening. So to set this up with something like Steampipe, I'm just going to copy our instrument, and then we'll open up Steampipe, and we can paste the instrument that we've just created into Steampipe. Go to Steampipe, go to the Connect tab Properties, and in the internal connections, select the instrument. And now you should be able to use our new version of Automata here to trigger some stuff. Alright, so we have everything technical working at this point in time, and in the next video I just kind of want to improve on some stuff and make everything a little bit nicer, add in some more features and knobs and all that stuff. So thank you guys for watching. I'll be back with some more videos very soon.